So this is the 0.96 inch OLED 12C display. We are using it to display our main menu on this panel. It basically has 4 pins as you can see here, namely ground, VCC, SCL and SDA. SCL is the clock line. It is used to synchronize all the data transfers over the 12C bus, and SDA is the data line. Now we have connected these 4 pins according to our use. This is a rotary encoder. Sir, it functions as an electromechanical device that converts the angular position or motion of a shaft or axle to an analog or digital output signals. Now this is a fuse holder. It is used here to ensure that all fuses are integrated safely within the electrical circuits. It makes sure that the voltage does not leak out to other components. As I mentioned in the fourth presentation, sir, we have used aluminum tapes inside in order to minimize the effects of the UV rays. Okay, so sir, here we have used an 11-watt electronic ballast. Its function here is to moderate the starting voltage and the voltage required by the components. Moreover, it acts as a voltage regulator. Overall, it affects the power, quality and the efficiency of the components. Okay, sir. So this is a prototyping board. It is a customized pref board which we use here to integrate all our components. As you can see, it has outputs for rotary encoder, OLED and read switch. Therefore, we have attached all these components here only. Okay, sir. So here are other components which we are using. The black cylinder is the piezo buzzer. It is used to produce an alarm sound. In our project here, we have used it to create an alarm buzzer which would get activated if the UV rays intensity exceed the safer limit. The 2 small green pins are the pin screw terminals. They are used here for electrical connection between the wire by tightening the screws within them. The blue cuboid here is SPDT relay of 5 volt. The full form of SPDT is single pole double throw. As to how it works, it is used here to switch high voltage or high current devices. Thus, it helps to regulate the voltage and current between the UV LED and other components. Meanwhile, ensuring optimal usage and no extra production of UV radiation. The black cuboid is 5 volt PCB SMPS, sir. SMPS stands for a switched mode power supply. It is an electronic circuit converting power with switching devices that turn on and off at high frequencies. They are also storage components like inductors or capacitors that supply when the switching is at its non-conduction state. Coming to the black pins, they are the N transistors. They are used here for switching applications and the amplification of circuit to avoid weak electric signals. The white pins are just simple connecting pins which we have used here to connect the rotary encoder, OLED display and read switch to the prototyping board. Okay, sir, this here is the main element in our component. This is the Arduino Nano. We have programmed it initially according to our usage and the code we have mentioned in our PPT. The Arduino Nano is a small, complete and breadboard friendly board based on the 80 Mega 328 Arduino Nano 3X. It has more or less the same functionality of the Arduino Duo but in a different package. It lacks only a DC power jack and works with a mini B USB cable instead of a standard one. Okay, sir, so now we have assembled all the components in the box with the UVC LED lamp attached in it, and this is our final project model. You can see here. Okay, so sir, coming to the working of this model, here on the LED screen you can see our interface just after we plug on the power supply. It has three modes: a manual mode, a timer mode, and a safety mode. We can switch between the modes using the rotary encoder and select the desired mode by pressing the orange button, which is nothing but the rotary encoder with the fuse holder. As we press the start button, the fuse holder connects the interface and power supply to all the components on the prototyping board, thus starting the UVC lamp for sterilization. We can also stop the process in between by pressing the stop button. Another mode is the timer mode. In this mode, we can select the exposure time from 1 minute, 2 minute, and 3 minute, and then press start to begin the sterilization process. You can see here the clock has been initiated